Welcome back to the workshop, and welcome to this ongoing series to add a little bit more functionality to this drill press. So in the previous episode you saw me debug the electronics here. All it took in the end was a capacitor on the 24 volt DC line going to the electromagnet on the brake system. So we got some basic functionality. This time we need to go a little bit further, so rather than just having some arbitrary speed, we need the speed in millimeters per second, and we need to get some of the other functions working as well. So let's get started. Alright, so to add those features we need to flash some new software onto the Arduino, which is there. Unfortunately I don't have a laptop and the computer is in the house, which is quite some distance away. Now I have been playing around over the past day or two with a Bluetooth module that I was hoping to interface with this, and then that might be just about within the range of Bluetooth, and then I could flash code onto the Arduino from my computer in there and at least, go backwards and forwards, try some code, try it out here and go backwards and forwards that way, rather than having to take this apart every time. But I got some way into getting the Bluetooth to work, but it didn't quite. I think I bricked it. I'm not quite sure what happened. Anyway, it stopped working after a bit. So rather than do that, we're going to do it old school method, which is to unplug all the connectors and take this into the house next to the computer and flash and update the software, debug it and make sure it's working before we bring it back. Okay, let's have a look at the programming then. So if you're not that interested in coding, just skip to this timestamp here and we can carry on with the rest of the video. Just thought I'd point this out. So I tend to save my files in different versions, so as I get through and add some more functionality, just increment the function or the revision name down there, and then I know I can always roll back if something goes wrong with the code, and that way I can see my progression. Sort of a nice and easy way to do it really. But let's have a look at the main code itself then. So I'm writing this within the Arduino's own IDE environment. Seems fine. You've got a serial monitor and various tools to help you to connect, so it's pretty straightforward. I'm not going to go through every line, but I'll just give you the basic outline. So I've got my versions up here, and as I add more functions, I can add more comments onto here as I upversion it. We're on version 12 at the moment. So we're including the library in here. This controls the LCD display, and I've also enabled the EEPROM in case I need to save any values to the EEPROM. I don't think I use that in the end in this. I'm just happy to keep it as default every time you boot up, just goes back to defaults. But I've got that in there just in case. I've got a load of parameters that define which pins I'm using for the digital and analog inputs, the direction, control pins, enable, things like that. This is the data, I2C communication with the data link here, clock and data on those pins, load of variables for the direction control, and then some to do with when you're in step mode, some to do when you're in the drill cycle mode, although I'm not using that at the moment. PWM, you need to know things about the pulse width and things like that. So the smallest pulse width that's accepted on the stepper drivers is typically 5 microseconds, so I've got that as 5, that's how long that pulse is. And then there's a load of other variables that work out the kind of frequency, so you're getting that correct. Then there's a load of calculations related to the screw pitch, number of teeth, revolutions, ultimately how many pulses do you need to move it 1 millimeter, and there's a few calculations there, including microstepping and things like that. Then we get onto a load about the acceleration which we implemented, and speed, velocity, some mapping and things like that in there. And then we get into the main setup. So we need to initialize the LCD screen, open the serial port, and then we configure some of these pins that it's going to read, so they're pull up in many cases. So all you need to do is earth those, and then it knows, or send them to ground, sorry, and then it knows they've been activated, like through buttons or e-stops, whatever. Motor configuration there, configuring the keypad, and then we make sure the motor's reset so it's not actually moving. And then there's a PWM frequency. I'm not using that in the end actually, so I could probably get rid of all that. And then we get into the main loop. So this is the loop that it continues around forever until you switch it off basically. So you're reading all the inputs from the user keys, buttons and things like that, and then you have to work out, right, what kind of drilling mode am I in? Am I in continuous, canned or step cycle? It looks at the condition of each of those pins to work out if you're in mode 0, 1 or 2. First thing it then does in the main loop is checks if you press the e-stop. Obviously that needs to cut the power, and then it doesn't do the rest of this. So if you're in e-stop, none of the rest of this runs, and but if you're not in e-stop, so in normal mode, the rest does run. So then we've got the speed control here. We're using a map function to map the Arduino from 1023, 0 to 1023 on the Arduino inputs, and then mapping that with an inverse onto my max speed, min speed in terms of millimeters per second. So that maps what you're doing on the pot into the velocity you want, and then it works out how long you need to delay in microseconds to get the pulse timing correct. And then if you're in draw mode 0, continuous, show some things on the screen. The main loop that it gets into ultimately is here. And in here you've got a number of things. So you've got actual sending the pulse out high, then it waits for the width of that pulse. So you're sending your 5 microsecond burst, if you like, and then it sends it low. And then there's a load of timing here, so it reads the current clock. And it waits when it goes around that loop again to make sure enough time's passed so it sends the next pulse out in time, and that then varies the speed of the motor, so it's time based. And obviously this is where you get a limitation of the Arduino, where it's got a certain clock speed and you could get saturated at certain speeds. It's also got some implementation for acceleration, so it bakes that in as well, so it's not instant. And that's all about going up. You've got exactly the same thing for going down. And then we go into step mode. Now this is similar. The only difference here really is you've got a step count. So you already know you want to go 1 millimeter, 2 millimeters. You know how many pulses that will be. So you can just send out that number of pulses. And then there's a little delay, which is just to a fraction of the main speed. So it's always doing a slower movement if you're doing steps than the main speed. But it just counts off those pulses, and when you're done, you must have moved the correct amount. There's some limit checks in there, e-stop, to make sure when you're on this mode, because I'm not running any auxiliary functions, I've got no interrupts. I've got a feeling that Arduino will only handle one interrupt. I'm not quite sure on that, so I've just got this code as flat. There's no functions called and there's no interrupts running, and just trying to keep it as fast and simple as possible. It's not a super long program. So it again checks the e-stop and limits while it's going through the steps, just in case during that step you had to hit a limit or you hit the e-stop, because it's trapped in this loop effectively until it's counted the number of steps. Similar thing on down. Here you might want to step down a certain amount, which is all this code. And then yeah, can mode, the drill cycle, mode 2, doesn't do anything other than tell you that on the screen. I'm wondering whether to use that or not, so ideas in the comments if there's some extra function we can add there. And then the last bit is reading the keypad, so we're checking which keys you've pressed, if you pressed up or down, and depending on which mode you're in, it does something like it adds something to the depth or the cycle step depth. Whatever mode you're in, those function keys do something slightly different. I think that's almost to the end. Again, we're checking which limits you've hit and putting a display on the screen. And I think that's it. And then there's a little delay, so it doesn't go around super fast. This is once it's done all the movements and it's waiting for the next key input. Just so if you do press something and you want to increment the step count, it doesn't shoot up too quickly, so there's a little delay. And that, in essence, is the code. Okay, so I flashed the code onto the unit there, and then to make life a little bit easier to debug it, I unplugged the stepper motor wire there, because obviously that's still in the workshop, and then plugged in this slave unit here, just so while I was testing it on the dining room table I could make sure it was going to work. And then I plugged in the Arduino there directly through the USB, straight into the front of the computer, and then obviously to power it we've got it running off that extension cable there, so the whole thing runs as it would do in the workshop. The only thing I couldn't do is check the limits because I left the switches on the machine, so I just used the metal end of this spoon just to check that was going to trip. So that was the lower limit. Yep, that worked. And then again, using the spoon on the 2 pins on the upper, shorting that out, making sure that works as well. Alright, back to the workshop. Alright, before we go any further, let me show you this. So this is some official Colin Furze tunnel dirt with his signature and limited edition name. And I picked this up from the Maker Faire, Birmingham NEC. So for those of you who don't follow Colin's channel, I'm sure most of you do, he's already dug a hole from his kitchen out to the shed through the back garden, and now he's going forward to the front of his house and he's digging all that up. It's all underground, and he's going to have a DeLorean, I think, coming up out of the ground on a turntable. So massive project. Obviously he's got loads of dirt and stones and rocks, and he was putting it in these jars. £10 a jar. Bargain. My wife said, do not bring back some £10 worth of stone from the show. Anyway, she doesn't know about this. It's in the workshop. Shh, our little secret. Okay, as you can see, I've made some changes here. So at the top here we've got the status, so it says OK, or if it hits a limit, or e-stops. There are all your kind of status messages at the top. And then you've got the mode you're in down here, continuous, step or drill, and then depending on which one you're in, there's some information about the speed or something related to that function. So I've got continuous, and we've got 5mm per second. If we're in step mode, it's going to go 5mm each time we push the button. And then I haven't implemented this yet, because I've got a feeling I probably don't need to. I might use it for something else, but it's there. And that was like the can drill cycle, if you wanted to sort of kind of peck drill to a certain depth using certain parameters. So the other thing I've done is added some acceleration, so depending on the speed that you've got here, it doesn't go instantly to that full speed, it kind of ramps up. Now, I was thinking about having it as a software parameter. You could go in like a menu, but it was going to turn into a lot of code to add that functionality to be able to interact with it. So I kind of messed around, and I've got a kind of fixed value programmed in terms of the acceleration. It's made quite a difference to the maximum speed. I think it nearly doubled the maximum speed I could get out of the motor, because you're not going instantly from 0 to full speed. You know, the stepper motor generally was stalling out, so that's a good improvement. I'll show you that in a minute. And then the step works as well, and I've got a few more functions when you're doing the step that work as well. So let's give you a little demo. Let's go into continuous and show you what it does. Now if we start with the speed quite low, it's a lot easier to see the kind of acceleration that it does. In fact, let's go down a little bit more, or maybe 3. That's quite slow speed, and then we'll just hit the up button. You can probably hear in the sound that the stepper motor kind of ramps into it. When you stop, it does stop instantly. I've decided not to do deceleration as well. I don't really see the need for that. So that works really well, and we can get quite a lot of speed out of it now. In fact, well, I was testing it in the lounge, so let's see how fast it actually goes with this stepper and this amount of mass on it now. Okay, 24mm per second. That is so much faster than before. Alright, let's keep going. I think the max in the software is 100, but I don't think this is gonna... Well, maybe. Let's go 50. Yeah, you can still hear that acceleration just ramping it in. 60, surely it won't do. Alright. Wow, the ball nut's going really fast. I might just grease it, sounding a bit... Yeah, I think the balls are making a bit of a noise. Let's go 70. Wow. Alright. 80. Surely. No, I don't think that's getting any faster. No. So I think what's happening there, essentially it does the pulse, and then it's supposed to wait a certain amount of time, but actually by the time it's come round and ran a few lines of code, it needs to get back round again to decide whether to send that next pulse or not. Too much time has elapsed to actually get that speed, so I suspect it's kind of plateaued and the pulses probably aren't quite correct, so I think we've probably hit the top. Oh yeah, that's definitely slower. Alright. Probably somewhere around there. To be honest, I think that's fast enough anyway. Let's put that there. Alright, pleased with that. Okay, next thing to check is the limits. Okay, upper and lower. Let's slow it down a bit. And we'll keep going and see if it trips. It does. Super close. Yeah, so you can see in there. No more travel left. Alright, I might adjust that up a little bit. Anyway, let's see how fast it is from here right to the top. Right, so set it at 75mm a second, which I think is about the quickest it's really going. If you turn it up more, I think it's just saturating the Arduino and it can't keep up, can't send the pulses out quick enough. So we'll go with that, and let's see how long it takes until we hit the upper. Right, here we go. Pretty quick. Okay, what else can we do then? So I've just slowed it down a bit and come off the limits. So obviously we can go up and down like that, moving the knee up and down, and then the other one was the step. So you can tell it how far you want to step in any given sort of push of the button. So you can go, I think 0.1. I might even let 0. Let's see what I did in the software. Okay, 0. For some reason I did allow it to go to 0. So let's say I want to go 1mm in steps. Now in terms of the speed, the feed rate, again I've thought about having a variable you could go into a menu and change it, but at the moment it was about 30% of whatever feed rate you've got here. That's how fast it will step up. So let me show you what that does. So we want to go up in 1mm steps. We just press this and hopefully. Now of course while you're doing that, so obviously you can step down as well. 1mm down, and while you're doing that, you haven't really got any control, so you push it and it goes down. Now you might realise that you've made an error and it's going to crash into the workpiece, whatever. So you can hit the emergency stop when that happens, and it will stop it. So, which is great. Then you can come out of there, and you're back in normal mode. Let's just bump that up because the next bit's a bit easier to explain. Let's do 5mm if we do that. Let's say we want a 5mm peck or step. So we can press go. Yeah, let me just show you for real. There is a button here which I've added called the select button. So when it's doing that step, if I press that, it pauses. Otherwise, when you let go, it will keep going. So it's kind of a peck drill, really. Obviously, it doesn't retract. That's why I'm thinking maybe I don't go for the full can cycle there. Yeah, if I want to drill something 5mm counterboard, put a cap head in, maybe. You press go, and then you think, oh, maybe it's loading up the drill. Just hold it there, clear it, let the swarf clear, and then let it carry on. So I'll probably use it like that. And then, as I mentioned earlier, depending on the feed rate you set here, so if we set that quite high, it'll take 30% of that for the feed rate when you're in step mode. So let's step down. You can probably hear that's moving a lot faster. Yeah. What's happened if we go full speed? Yeah, that's full. I guess you've got to remember to turn that down if you go back into normal drilling mode, otherwise you'll be whizzing along quite high. Anyway, that's what I've got so far, and yeah, pretty pleased with it. I think I found the cause of that noise earlier. I thought maybe the ball screw needed a bit of grease, but taking the covers off, it's not that. It shouldn't have that free play, and when I do that you can see the coupling's not moving, which it should be attached to. So something is loose in here, and I think it's the grub screws of this. Yeah, you can see that shaft's not moving there. So it's just come loose there. Hopefully I can get a little Allen key into that gap there and tighten those up, and then it should sound a bit nicer. Alright, let's try it again. It sounds a lot smoother, but I think the little nipple there is rubbing on the plastic casing. Let's take this off and see. Yep, that was it. Obviously just rubbing around there somewhere. You can sort of see it a little bit. Well, I need to make a new one of these anyway, because you can see pulled away from the bed. So also I want to make this again, a bit more relief around there. I'll probably put some relief slots, vertical ones in here all the way along, just so it can't pull. Because it's got some breaks in all those, and then I want to make this end actually wrap round and come over the top of the lower piece, that kind of covers it and encapsulates it like that, and give you a nice fit and finish on there. At the moment it just butts up against it, you know, and if there's a like 0.1mm gap, you can see that it's out. So we'll do that in the future, because I think it's took about 3 hours to print, so I'll make sure there's no other feature I want to put on it, and then we'll print that again at some point in the future. Okay, so we discovered another small problem. So we got this set to 5mm in the step mode, and then when we press up, what I'll do, I'll just zero the DRO on the knee, and let's see how far it goes. It's almost at zero, but we'll zero anyway, and then let's go up 5. Okay, so pretty happy with that, within 20 microns, so yeah, that's fine for what we're doing here. Alright, 15. And we can do that again. Okay, so alright, so within 15 microns, 20 microns, absolutely fine. However, when we change direction, so let's zero that, and we'll go down. Yeah, as you can see, we're missing by about 0.5mm. And I found the reason why, and it's down here. So hopefully you can see here, so we've got the ball screw and the pulley, and then there's a thrust bearing there. So there's the upper face, the part that carries the rollers, and then the lower face, and then there's the top of this bearing plate, the main housing. So that's all in a line. Then underneath, at the bottom there, the black bit there, that's a circlip, and there's a tiny little bit of clearance, and I kind of assumed that the amount of preload was always going to be such that it wouldn't really move. Now in one of the earlier designs I did have a screw on there, or a big kind of lock nut, and another thrust bearing on the other side, so it would be sandwiched, preloaded, and then it wasn't going to go anywhere. But I think in the end I made the housing a little bit too short accidentally, and I couldn't make that work, so I just put that little circlip in there. However, now it does this. So I think we've just gone down, haven't we? So let's go up. Did you see it compress then? Right, and then we'll go down. They are lifted. And in fact it's, I don't know if you can see under there, but it's lifting until a little circlip bottoms out there. So it's got 0.5mm of end float. I mean, not the end of the world. I could always make sure, you know, old school machining, you know, you always take out the backlash first before you go a certain direction, but something about that says I'm not going to be happy with that, so let's see what we need to do to fix that. As I just mentioned, on the original design I was going to have it so it was trapped on both sides, and it had thrust bearing on both sides, so a needle roller effectively, which looked a bit like this. And so what you've got is, you've got the ball nut at the top here, which obviously got the thread inside it to move the ball screw up and down. That's bolted onto this pulley here. And then the pulley in turn was a press fit onto this long tube, and the long tube went all the way through, went past the thrust bearing on the top, You got the radial bearing here, so it holds it radially, and then there was a spacer, and then another radial bearing, and then again to stop that end float the other side there was a thrust bearing, same as the top. And then in this one I'd put 2 lock nuts. Whether you need that or not I don't know, because I was going to put a grub screw with a brass insert in it, and that would push against the thread, so probably lock it in place with just one. But on the original one I made, for some reason I made this part too short, and I couldn't get a bearing and the thread on it, barely came through, so I just put that little circlip that you just saw a minute ago. But I had to be careful, I didn't want to underplay it, so obviously I've left myself a little bit of float, and that 1/2 mil of float is causing me issue. So back to making this one then. So in terms of that, the parts I need to make, well, first of all I need to disassemble the machine again, the lift mechanism, get it apart, and that part there, that tube, is pressed into that there because it needed to be quite a tight fit, and then it was a very good fit in these bearings here, these radial bearings this way. So I may have to machine that out to get it out there because it was pressed in, because there was no way of making a fixing unfortunately between this part and that part, because the threads just weren't in our favour in terms of where they needed to be to put the ball nut in. Anyway, so that existing tube that's too short will have to be removed somehow, and then I'll have to go back to the original plan of making the tube. In principle it's very simple. You got enough clearance here for the ball nut housing to go down, so that it's normally about 28, so 28.1 is fine. This 40mm is pretty critical because that's got to press into the recess I've already machined into the top of the pulley, so the pulley's sort of up here. And then also that 40mm's got to be a nice fit in the bearings, so there's a lot to get pretty accurate there. And then I've got this thread here, which, because this is 40mm, I'm having to drop down one in size, 39.15. I may go for 39.1, we'll see. And obviously I haven't got a die set that big, so we'll use the lathe and electronic bleed screw to do that. I've just put the major diameter tolerances for that type of thread on here as well, and I'll probably shoot for somewhere in the middle, because the nut that goes with it, now I could make 2 of these, but actually I think I'm going to make just one. So here's our nut, and we've got our thread there, 39 by 1.5. Again, we've got the minor diameters and the range we'd want to aim for. But what I'm going to do is cut it, and I'll cut this part first, I think. Female thread first, like that one. And then put this in the lathe, and when I'm opening this up, just use the other one as a plug, because it's a one-off, you know, this has got to match that. Because I think that could be a bit awkward to measure there. I've got some wire gauges to measure the thread on the outside, so I should be able to get that within spec, and then we'll just machine this to suit. And then the only other thing is a lock screw there, which will have a bit of brass thread, or a little brass bar that pushes on the main thread, grub screw. And then these I think were a standard width apart, I seem to remember, or I might have to make a custom pin drive just to tighten this up. I think that's it. So in terms of materials then, so for the main tube there, I found this little bit here that might be quite useful to hold it in the lathe, get that down to size, so probably get that out of there. And then I got a bit lucky, I'd forgotten I'd made this. This is the actual original ring, basically to this drawing without the thread. It's got a grub screw in there, it even has a little step relief in it to push against the axial bearing. So that's pretty much ready to go, apart from the thread in there. So I got a bit lucky there, and I think, as I say, I'll just make one. Okay, so I'm not going to get on this for a couple of weeks, I think now. So rather than wait that long, I thought I'd put all the video together. We got the update for the software, we got the draw mode, the step mode working. We fixed one mechanical issue, which was the grub screw on the pulley that came loose. So that's all now working. I think I do need to reprint the covers that go over the top. I have had one go of that, or a couple of goes actually, and it's still pulling away from the bed. I've got some thoughts on where we can go with that. And what else we're doing? Yeah, we now know we've got Backlash, and I think to make this machine I want it to be, I'm going to do it properly, as was the original plan, and we'll make these parts, but we'll do it in the next video. Okay, so that's it for this video. Hope you've enjoyed watching. If you're enjoying this, feel free to subscribe, hit that bell if you want notification when I upload the next video, and with that being said, see you next time.